Oh, we lost one, no? But no, easy. He just moved. Okay, perfect. For you, because we have two guests coming from far away, we'll do it in English instead of thank you, Christoph. Oh, wow. We get something from a.
Oh my God.
Oh, I need a present. I get a birthday present for my wife.
Since live verschiedene to it's what is eBPF and it's
Somebody mentioned this yesterday evening already that you are going to have some presents.
Oh, wow. Super. Yeah. And, okay, as I am the...
But that is typical for Cisco, right?
we had this before Cisco.
Okay.
Way before Cisco.
Way before. Hey, and just 2 weeks ago we spoke with Gerd about the agenda, and Gerd told me 2 weeks ago, oh, I have a good idea, we do a session about, thank you that you have a t-shirt with eBPF, because I would have even not remember the abbreviation. We do a session about eBPF. My goodness, what is that? I have to Google it, and then I found it a sort of, okay, API are bad, we need to go directly to the kernel and to be much faster and efficient. Wow, looks very interesting, very, very interesting. Did you hear something about eBPF already? Uman and Ku? Oh, you Googled it like me? Oh, perfect.
Okay, cool.
Yeah, you know,
I used the original Berkeley packet filter in my first job when I was programming a NetFlow collector by myself.
NetFlow collector.
When was that, Oli?
That was in '99.
99.
This exists already?
Yeah, the BPF without the E.
Ah,
Yeah,
BPF.
on FreeBSD. That was odd as.
Anyway, we are very, very happy to have Christoph, and the floor is yours. I don't want to make a long introduction. I think we'd like to see what you are bringing us.
Okay, cool.
And please tell us if it's a dream or if it's reality during the session.
Oh, wait, I will. Yeah, so Gert just told me I only have 30 minutes, which is usually my first 10 slides. I shortened most of my slides. I removed all the screenshot stuff because I'm trying to show it live. My demo is broken, kind of. But I think the most important stuff still works. So I'm going to talk to you about 3 things today. eBPF as the underlying technology for 2 open source tools. One is Cilium, one is Tetragon. Have you ever heard about either of the 3? Everybody cool. Perfect. So yeah, first of all, we're going to quick primer. What is eBPF? Why did Oli use it already 25 years ago? And why are we talking about it today? Then a lot of Kubernetes-centric stuff, because everything we're doing with eBPF on the networking side is purely based on Kubernetes. So I think and hope that everybody is aware how Kubernetes is working. Cool. Talking a little bit about this, what we can do with Cilium as a CNI in Kubernetes, how we bring security into Kubernetes, how we make traffic flows visible. And at the very end, we're going to touch on Tetragon, which is a runtime component that allows us to observe and enforce processes within Kubernetes pods and on general purpose Linux machines. Perfect. Let's start with the principles and the distinction between the company Isovalent, now part of Cisco, that I'm working for, and the 3 open source projects we're talking about. So as mentioned, eBPF is not a new technology. I think it's in the Linux kernel since roughly 10 years. Tetragon and Cilium both are open source projects that use eBPF underneath, but that abstract the interaction with eBPF. As Oli said earlier, it's pretty hard to interact directly with eBPF programs in the kernel. Hence, we have built tools to make it easier to do an abstraction layer via the Kubernetes API and make it really easy to use eBPF and not to touch eBPF. Isovalent was essentially founded by 2 guys. One of them was kernel engineer at Red Hat and was at the original team 10 years ago bringing eBPF into the kernel. And based on that, they said, okay, now that's in the kernel, we need to do something with it. And they started building Cilium to make it more consumable for the broader industry. So eBPF itself is a Linux kernel technology that allows to inject small programs into the kernel during runtime. So you don't need to recompile the kernel if you want added functionality. You don't need to use like kernel modules that may break your kernel. eBPF is really pretty safe to use. There's a just-in-time compiler that makes sure that that the program you're trying to inject is safe, it doesn't blow up your kernel, and you can attach those eBPF programs to different kernel functions and to different events in the kernel. So we can attach eBPF programs to all of the different networking points in the kernel. So once a socket gets created, we can attach an eBPF program and already decide there with the CNI if or if not the packet is allowed to go on the wire or not. Right? We can manipulate packets, we can redirect packets, we can drop packets, all of this. On the left-hand side, we see the string that Tetragon is using, where we can really look into workloads. Like we can then see which process is doing which network calls, has which Linux privileges, so that we can identify things like people trying to escalate privileges within the container, make this visible and act on it. All right. If I'm going too fast, please let me know, but I'm trying to be fast to come to the demo. In Kubernetes, there's something called CNI, which is a container network interface. This comes with every Kubernetes distribution. There are different sorts of CNIs, but the main purpose of a CNI is actually to provide interconnectivity between containerized workloads, either within a Kubernetes worker node or between Kubernetes worker nodes. It abstracts the Kubernetes services, so the virtual load balancing within Kubernetes, and it may or may not be able to provide security. When we're installing Cilium as the CNI layer in Kubernetes, we essentially replace it with an eBPF-driven data plane, meaning that we don't rely on IP tables anymore. We completely can replace a component called kubeproxy, which usually takes care of service abstractions, and everything we're doing is based on eBPF. So for every packet or for every pod that we manage with our CNI, we have the respective eBPF programs in place to manage the interconnectivity and the network security for this workload directly in the kernel. Why are we doing this? Oh, the big slide first. So when we are doing this, we bring a bunch of networking features, of advanced networking features into a Kubernetes cluster that usually are not there with standard CNIs, right? First of all, we are completely agnostic when it comes to the Kubernetes distribution. So it doesn't make a difference if we're running on AWS EKS, on Azure, where my demo currently is running, or on-premise on OpenShift, right? You get all the features on all the different Kubernetes distributions. And the main features that we want to discuss today is essentially network security with network policies. So making sure that we are building a zero trust networking approach within the Kubernetes clusters or across clusters. And I'm going to touch on the observability portion. Because as we're touching every packet, we can report on every packet and make every flow that's happening in the cluster or coming into the cluster or leaving the cluster, we can make it visible, and we can ship information about that out of the cluster. I'm also going to show you a little bit about Tetragon, like how we can enforce stuff on the file system, how we can make network connections visible without instrumenting the application. Right. I'm going to skip this. So why are we doing eBPF and not IP tables anymore? IP tables is not a really new technology. IP tables is a linear list of rules, right? So whenever you're using IP tables in Kubernetes, which is the standard way of things, how things have been done earlier, is that once a packet leaves the pod, you first of all have to run through all the IP tables rules until you hit a rule that's either like taking care of load balancing of destination NAT to endpoint, or that disallows a packet, right, for security purposes. In eBPF, everything is based on hash tables, which means that once we inject an eBPF program, we can much quicker come to a decision if or if not a packet is allowed to go on the wire, and if it's allowed, what we should do with the packet, right? Also, if your Kubernetes cluster scales and you have like a lot of workloads coming and going, in IP tables, every rule, like all the rules have to be replaced once. In eBPF, it's just a single program that needs to be touched. Some of the advanced networking features we're bringing is, for instance, load balancing. It's not really advanced, but if you think about how you bring traffic into a Kubernetes pod, usually when you're using cloud-based solutions, there's always like an automatic creation of a load balancer for your Kubernetes cluster. If you're doing this on-premise, you need to take care of this yourself. So if you're running OpenShift on-prem, there always needs to be some kind of load balancer in front of your cluster, may it be an F5, may it be an A10, whatsoever. And these integrations are mostly pretty clunky. With Cilium, we can work completely without a load balancer, so we can set up BGP connections to the existing world and advertise the virtual load balancer IPs simply via BGP to the outside, so we can replace F5 basically for on-prem installations. To interact with, I would say, classical firewalls, once I had a presentation with GERD, I put a Fortinet logo up there. To interact with classical firewalls, we have the capabilities to source NAT packets from different Kubernetes workloads to specific IP addresses in the underlay network, so that the underlay really understands like from which workload this is coming. Because usually if you think how Kubernetes sends traffic to the outside, it's like everything running on one Kubernetes worker node, no matter which namespace, no matter which application, has the same source IP address in the underlying network. And with this, it's just like a policy that tells us like application A gets this IP address, application B gets this IP address, and we're doing the source NAT so that you don't need to over-provision a traditional firewall. We have a feature called cluster mesh, which allows us to use all the networking functionality across Kubernetes clusters. So if you have multiple on-prem clusters, if you have EKS connecting back to OpenShift on-prem, we can do that with Cilium and provide the same network functionality throughout the whole stack, right? So the Kubernetes API itself is pretty much standardized across all of these different Kubernetes distributions. The problem is that every Kubernetes distribution usually comes with its own CNI. So the networking layer has like a different API if you're running on AWS compared to if you're running on AKS on Azure. With Cilium, we bring our own CRDs, so we're pretty much standardizing the networking APIs as well across all of your clusters. Right. What are the main use cases for interacting or for having a single networking layer across multiple clusters? It's first of all failover, right? If you have a service that's failing in the one cluster, we can make sure that traffic is automatically rerouted via eBPF at the very end of the day to a cluster where traffic, like the service, is still available. We use this for centralized services as well as for stateful clusters. Because like, has anybody ever managed state in a Kubernetes cluster? No? It's not fun, and that's the reason my demo is broken, because my state is shit. I can show it to you later. Right. When it comes to security, every network policy that we're enforcing in Cilium is actually based on identities and not on IP addresses. Because IP addresses in Kubernetes, they're pretty much meaningless, because IP address A can be with application A now, and in 5 minutes with another application. Hence, we're using all the available identities in Kubernetes, so we can use labels, we can use namespaces, we can use deployment names, service names, things like that to build our Kubernetes network policies. We also have the ability, if we're running, for instance, on AWS, to use cloud metadata to build policies like which is targeting an EC2 instance or what for traffic that's coming from an EC2 instance. And all of this, again, is not only working in a single cluster, it's cross-cluster if we want to. The network policies we are supporting are more than the standard Kubernetes network policies. Standard Kubernetes network policy is layer 3, layer 4 only. With Cilium, as we're having our own CRDs, we do support layer 7 as well. So we do support like checking HTTP API requests. We can also do DNS interception, which allows us to use FQDN policies. So if we're targeting something outside of the Kubernetes cluster with a policy and we don't have the IP address under control, and it may change over time, as we're inspecting every DNS request, we can make sure that the eBPF program enforcing the policy is always up to date with the latest IP address of the
I
destination.
have a question to this.
Yes, please.
If you build up a rule on FQDN, do you have to be in the forwarding path of the DNS request, or you, in the case if you create this kind of an object from this rule, are you going to ask the file what's the actual IP address and then use the IP address instead of the... how is this done? So how is the IP address matched to the FQDN?
We're doing DNS interception. So at the end of the day, it's eBPF.
You have to be in the forwarding path.
We're putting ourselves in the forwarding path, yes. We're injecting an eBPF program that intercepts the DNS requests, puts it through the Cilium agent that does the inspection, and then we're using like the original destination DNS and traffic backwards coming.
Okay. Can you also work with fully qualified domain names with wildcards?
We do support, as you can see here, there's a wildcard.
Okay.
We cannot only build policy on the destination FQDN, we can also build policy to allow only specific DNS resolutions. So if you only want your Kubernetes pods to resolve your local domain, then we can put a policy in place and every other DNS request will simply be dropped. For HTTP, I have brought an example here, but I just want to make the point with this example that we are 100% Kubernetes API driven. So everything that's being configured in Cilium is done through the Kubernetes API. So customers that are having existing workflows, bringing objects to Kubernetes, they can use the same workflows for the networking in the future with Cilium. Okay, the observability part. Time was still okay. For the observability part, we have a component called Hubble. Hubble is part of Cilium. It runs with the Cilium agent in the same pod, and it tracks every packet that Cilium is handling. Right? We do have our own UI. I'm going to show you in a second. We have our own CLI. I'm going to show you before the UI, and we provide the standard metrics endpoints to make it visible in Grafana at the very end of the day. So, yeah, we're starting with the first demo in my broken environment. Perfect. All right. So the first thing I'm going to show you is this big enough? First question. No? Ja, Gerd, dann
Komm näher.
sieht's so Arsch.
That's what you've seen.
Was? Okay. Gucken, ob es jetzt größer wird. Okay. First thing we're going to do. So, first of all, what do I have? I have my own namespace here, and I have a pretty crappy application because I'm not a developer. I have some traffic generators that are generating traffic. They're calling a front-end component, which in turn calls a back-end component, and they're calling to the outside world. What I'm now going to show you is the Hubble CLI. So it's pretty much a live troubleshooting thingy if you want to see what's happening right now in your cluster. Right? So what I'm going to do, using the Hubble CLI to just observe traffic in my namespace. Right? So this is pretty much understandable for every human being, I think. It shows us the source pod with its identity. So we have our own Cilium identity system, which at the very end of the day is being used for the policies. And it shows us what it's doing, right? So we see here, it's calling core DNS on port 53. So it's most probably a DNS request, right? We show everything that's happening to a packet. So we're showing if it's forwarded, if it's redirected, or what else happens with it, if it's denied. This is the human readable way, but we also have everything in JSON, which is used for essentially if you want to ship everything to a seam, right? If you want to ship all the information, all the flow information we are seeing within Kubernetes or traffic leaving Kubernetes to a seam, we do have this in JSON, and every flow here has much, much more information than what we just saw in this human readable way. So we see like the actual IP addresses, even though they're meaningless. We see what's the layer 4 protocol, and if we have layer 7 traffic, we also see the layer 7 portion here as well.
Is there any SIEM system which already has a converter or a package interpreting the human readable stuff?
We do have a lot of customers using Splunk, and we did this before the Cisco acquisition, Oli. So for Splunk, we have a lot of prepared queries to like digest this JSON, but theoretically you can ship it to everything that's capable of receiving JSON export. Right? We also show you all the Kubernetes identity from the source and the destination here, and Kubernetes worker where it's running, things like that. We can also
how is it connected with your Kubernetes? In Kubernetes you have your Cilium policies.
Yes.
And how you centralize it from your different YAML files.
What do you mean how I centralize it?
Where have you your YAML files, or where have you your Cilium policies? Where you configure it?
They're configured.
Here centralized configured.
They are configured in Kubernetes itself. So
sure. But how it comes together to have you some tiering, or how is it going?
What do you mean with tiering?
Yeah, you have different applications, namespaces, whatever.
Yeah.
And then you go usually in your Kubernetes CLI, and then you put in your policies.
Yes.
And how is it structured? How in Cilium?
The structure. It's not.
How you get your policy set from?
Okay.
You know what I mean?
I'm going to jump over here. Maybe
Yeah.
this answers your question a little bit. So how Cilium network policies work is essentially, first of all, it's our own CRD. So this is something you deploy against the Kubernetes API. We have, first of all, have like simple name and in which namespace this policy should be applied to. And we do usually label matching. So with an endpoint selector, we can say like for which endpoints this policy should apply, right? And then for these endpoints, we define egress rules, right, to other endpoints within the cluster or to an external FQDN. And we can also do the same. Let me check here. There's something with ingress rules, right? For ingress, no. There, here we go. Right. For ingress, we do the same, like we instruct, is it coming from the outside world? Is it coming from another Kubernetes entity here? And like, what are the allowed ports and layer 7 path that we allow traffic? The policies themselves, they are not structured like a traditional firewall, like a sequential model, as everything is built in eBPF. Does that answer your question, Jörg?
And how can I find this rule now in your, what you have shown before in your JSON file?
You will not, like the JSON file was live traffic.
Okay.
In the JSON, there is somewhere we grab allowed. There's somewhere. There should be. Right? Fail to connect, port forwarding. Told you my policies.
Yeah, but it's clear now, it's the live traffic, okay, now I got it.
Yeah, it's the live traffic, but in the JSON.
That's the configuration, okay.
Okay, no, that was live traffic.
Yeah.
But in the JSON itself, you always also get the information like which policy allowed the traffic in and out the pod.
But this is Helium, isn't it?
This is Cilium.
Hubble.
Hubble, which is part of Cilium. Yes. Right. So these flows you can ship to wherever you want, but we also have our own UI, which is the Hubble UI. And with the flow logs, we essentially like show you the flows down here. We can also like show the live flows happening, and we automatically generate a service map, right? So we see my namespace here, we see my 3 different application tiers, and we see traffic going to the outside world. We see that like Google on port 80 is being dropped because I don't have a policy in place. We can see this in the CLI as well. If we're going here and saying like only show me the dropped network flows, then we should like now and then theoretically see traffic to Google being dropped. Here we go, right? We see a traffic generator going to Google on 80, not working as intended. Right. Where did I stop? Right. We built the own service map, and this is essentially like where like if we install this in customer environments where the big aha moment often happens because they see namespace crosstalk they're not aware of, they see test talking to prod and things like that.
This is comparable like running from VMware to get the flows in and then visualize where the flows are going.
Yes, yes. We also have the ability to put a time series database behind all of this, so we can go back in time and see the flows for the rest of the day. And this is where my demo is broken, because my time series database now seems to be completely dead.
And you look at all the flows, or you can choose that you have a kind of a control of the picture. So if you have all the flows, I expect in a normal environment you have thousands of these connections.
Yes.
Is there any help for you to make it application aware or what have you?
So in my environment, I'm simply looking at everything.
Yeah.
In real life environments, you can decide at least which namespaces you want to be exported in the flow export. Yeah. What you see here is essentially the flows over the last days, and then when I entered the building, like at 6:30 roughly, my demo broke. What we're also doing with the time series database is we're tracking policy changes. So we see that this afternoon I added some policies, I updated some policies, so that like people can easily correlate if a policy change correlates to traffic being dropped in the network. We do have integration in Grafana, as mentioned, and we are pulling Grafana dashboards automatically in the Hub UI so that we get like a centralized picture. Should work. Yeah, doesn't work.
So at the end of the day, Hubble has an integration to Grafana and Prometheus, or
Yes, Hubble is simply providing these standard Prometheus metrics endpoints that can be scraped by service monitoring. Yeah. The reason why we're doing this here is that we do have role-based access control on the UI. So if, as a platform provider, you want to give visibility to customers, you can make sure they only see their namespaces and they only see the Grafana stuff of their namespace without giving them access to Grafana directly. So, all right. Any questions on Hubble, Tetragon? No?
No.
Cool. Okay. I'm going to skip the service mesh part, if that's fine for you. Long story short, we're doing sidecarless service mesh because we have a lot of functionality that classical service mesh provides already in the kernel. Hence, we don't need a sidecar proxy for everything. Okay, let's come to the Tetragon stuff, because I think this can be relatively interesting. Tetragon is meant to provide insights into what's actually happening process-wise within a Kubernetes pod, right? So we can do things like TLS inspection, like if there are compliance things that you need to fulfill, we can, with the help of Tetragon, inspect TLS traffic, inspect the ciphers that are being used, and make this visible, ship it in SIEM again to make sure that you're compliant. Tetragon is, first of all, also part of the Hubble UI, so everything we see in Tetragon, we can also do the flow export, the JSON export, we can ship it to our own UI, and we can ship it somewhere else. In our own UI, it looks something like this, right? This is one of my traffic generators, so we see what's my pod name, what's the namespace, what's the cluster. We see all of the container runtime that's actually holding the pod, and then we see every process within the pod that's happening and when it happened, right? So we see that my traffic generator, super stupid curl, it does a curl, so my curl process, like every 10 seconds or so, reaches out to Google and does a DNS request up here, right? So we can make all of this visible. And what I want to show you guys is essentially I want to jump into a specific pod. I'm going to do stuff on the top and you will see stuff on the bottom, right? I'm going to jump into a pod that usually doesn't do much. So first of all, we're going to check like what's happening in all of my namespace before we jumping into this. Whoop. Why is okay? Wrong pod name. I need to find my pod. Give me just a second.
Did you forget to break to the demo box?
Yeah, I already told you that it's broken. Yeah, perfect. So we do see something, right? We're now looking at Tetragon, which is not in the traffic path. It's not touching any packet. It's just inspecting from the outside what's happening. So we see a lot of sockets opening. We see some connections opening. We see connects closing. We see DNS requests happening. And down here we, for instance, see TLS. So what I want to show you now is I want to show you how we could do TLS inspection from the outside. No. Again, wrong. We need this. Cheat sheet. Right. So now I'm not only looking at my namespace, but also filtering on my pod up here to show you what we actually can see if I'm doing something. So if I do a simple curl to Google, right? I see a lot of stuff going on with this single curl request, right? So first of all, I see my curl process starting. I see it's doing a DNS request. I see all the DNS replies. And then somewhere down here, I should actually see my connection happening to Google. Like there's the connect to google.com. And I can inspect from the outside what the actual TLS ciphers are that are being used. Right? So I see it's TLS 1.2 in this example here, which is good. And I could also, if I'm changing the TLS is it v1.0? Yeah. If I'm changing my TLS, I see all the same things happening again. My process starts, does DNS request, and I see here that I'm now using an old cipher, right? In Tetragon, also, we can export all of this stuff in JSON format, which is pretty intense. I should show you a slide, which I don't have with me. But essentially, here we're showing like everything related to the process So we show the Linux capabilities, Linux user IDs, the parent processes, the arguments, the working directory, things like that, right? That was the TLS inspection. What we also can do, we can get information about what's happening in a file system, for instance. So I have currently a policy deployed that looks at my /etc path in my namespace and informs me whenever somebody writes to this path or deletes a file from this path. So
and how is Tetragon getting this data from Cilium?
no, it's not bound to Cilium at all.
This is from the Linux kernel directly?
Yes. Tetragon is also capable of injecting eBPF programs, so it's not bound to Cilium, it's not even bound to Kubernetes. So Tetragon can really run standalone without Kubernetes, without Cilium.
Is this a use case, by the way?
Yes.
Okay.
Yes. I think all of you have heard about Hypershield nowadays.
Yeah.
The next big thing from Cisco. Yeah, Tetragon is like the main product underneath.
Okay. So no rocket science.
No, not really. So what I can do now is I can actually copy a file, write a new one in my /etc path. Pretty boring. And I see down here, Tetragon shows me there's a process, my copy process, which is writing a file to this path. If I remove the file, I actually get the delete information, right? So I can monitor who's doing what, but with Tetragon, we're not only providing visibility, we can also proactively enforce stuff, right? So if instead of saying give me a notification about this, I can also change the action and I can redeploy the policy, and now I have the action block, which means that now whenever I'm going to try to write or delete a file from this path, there's eBPF program in place that will simply not allow it. That will exit my process. So if I'm trying to copy the file again, why was it? Okay, maybe I was too fast. It takes some time until we actually deploy the policy. Why didn't it deploy properly? Okay, so theoretically, this should have worked.
EKS oder AKS?
Nee, meine Policy liegt in EKS, aber eigentlich sollte es die richtige gewesen sein. I told you it's broken. Try it again. Maybe it works now. Now it works. So it took some time until the policy made it from the Kubernetes API into a eBPF program, but now we see that my copy operation is not permitted anymore. I'm getting the notification that again my copy process wanted to copy a file, but this time I have a different exit code, and I'm also not allowed to delete anything.
What happens if you push a new rule set between the new rule set is used and the old one is flashed? Is there any kind of
Oh, you've just seen it.
allow anything?
You've just seen it.
Does nothing, or
Well,
is it deny any or allow any?
when?
In this time, so you have an old rule set. And
Oh no, the old will be used until the new one's there. Because
so it's really it's not like in good old times at the TCAM at Cisco. You delete the old one and then compile the new one.
No.
And
No,
nothing happens.
No.
Okay.
um,
And is this true for any size of rule set, or so if you have a huge one?
oh, you missed the first part when I was talking
Yes.
about IP
Yeah,
tables.
sorry.
Yeah.
You cooked a pizza at that time.
Yeah.
I'm a pizza cook.
Yeah, that's why we're using eBPF, because traditionally, for instance, in IP tables, you needed to replace all of the rule set. In eBPF, we can really just like replace the single eBPF program that takes care about for like the specific traffic flow.
And is there any kind of an optimization if you handwrite your rule set? Most probably it's not optimized.
If you handwrite it,
Yeah, if you set up a rule set.
oh no, it's most probably not optimized. We do provide a policy editor built in, which essentially visualizes the policy and which allows you to add rules to the policy like in a syntactically correct way. But the rule set itself, every customer needs to build on their own. Right?
Okay.
Like in the future with Hypershield, there will be the AI doing it, but for now, it's like build your own.
Magic words, AI.
AI is always the answer.
Yeah. Okay, last 2 slides before I'm gonna leave.
Last 2 slides.
Yeah, like
Christoph.
what we've seen
You're thirsty.
just now with like access to a simple file, killing a process. How can we use this in real life? Like I think everybody has heard about the XCutils,
Yes.
where someone made, after years, put a backdoor into libraries for like a lot of open SSH daemons out there. With Tetragon, we can not only figure out if somebody is like vulnerable by placing a policy in the Kubernetes cluster or on the Linux machines that are out there, and we can inspect when OpenSSH starts if it's loading the vulnerable libraries, so we can make this visible. But as you've seen earlier, we can also like react on it and simply like kill the process and do like kind of virtual patching. With that, I'm done. If you want to learn more, there are labs available at isovalent.com/labs.
Just to give kudos to this labs, I saw this today, and it's not only interesting and you learn a lot with these labs, you also will get a badge which goes directly to your Credly thing, and you can then propose with this. But it's really cool labs.
So this being open source, everything, Tetragon and Cilium and how is Cisco making money out of that?
Oh, we are providing an enterprise-grade version of both of the products. So some things I've shown today are enterprise-only, like for instance the time series database.
Okay.
This is not in the open source.
Okay.
Yeah. So there are features in addition to the open source.
But
Plus.
you can use the GUI with open source?
Like the open source UI is pretty much like is this. There's no menu, there's just the flow and the service map. There's no time series database, no Grafana integration, no policy editor, but you in open source you get the service map and the flow data live.
Okay.
Yeah.
Who holds the copyright to the open source? Is
Um,
it now Cisco or is it the Cilium organization?
No, like Cilium and Tetragon are both CNCF projects by now. So it's the CNCF owning them.
That means Cisco can't change the license.
They cannot.
And with the cluster mesh, what you have mentioned, you mentioned that you can also have integrations to AKS, for example. Do you replacing the CNI there?
Yes, yes. So I'm running on AKS. My complete demo is on AKS
With Cilium.
with Cilium.
Okay.
It's simply replacing the CNI. In AKS, it's bring your own CNI. On EKS, we're replacing the AWS CNI.
Wow.
Okay, I think we make a break. Christoph is still here,
I'm here.
but we go for pizza and beer
Can I join
to
you?
the kitchen. Right?
Can I join you for pizza?
And you join us
Thank you.
for people who like to drill down. Thank you. Thank you very much. Sehr interessant. Oh no, the pizza coming to us, we do not have to go
Oh, wonderful.
to the kitchen. It's even better.